Hi, my name is Alexandra Hoya. I'm from ECE 41 and this is for my robotics laboratory subject. It is laboratory activity number 1, DC motor controlled with computer and microcontroller interfacing. So the objectives of this experiment is to control the direction of rotation of a DC motor using H-bridge circuit. Number 2, to control the speed of rotation of a DC motor using pulse width modulation. 3. To create an Arduino programming to control the DC motor. And 4. To create a computer program user interface to send data control to Arduino. So according to our professor, this fourth objective here is not required in this experiment of ours. So we just have to skip this objective. Next, the equipments and materials used for this experiment. Equipment and materials: a personal computer, one Arduino microcontroller, one DC motor, one power supply. For the power supply, I would be using this cord. This end of the cord here is to be connected to the power port of the Arduino Uno, and this one is for the personal computer USB port. One breadboard, alligator clips, one set of connecting wires. So as you can observe, I almost have all the equipments and materials that I need for this experiment. The only problem that I have is that I don't have this L293D motor driver. This is because it's still in transit from the seller to our home. So because of this, I cannot be able to do the experiment using the Arduino kit itself. So I would be using applications like Tinkercad from Autodesk and Fritzing for me to be able to do the experiment. So moving on, introduction for this experiment. The objective of the experiment is to control the speed and direction of the conveyor with the use of the DC motor. With this, the members will use motor driver, which is L293D. The function of this motor driver is for the DC motor to change its direction from clockwise to counterclockwise and vice versa. MS Visual Studio provides GUI to control the Arduino board. When you input a command in the program will trigger the Arduino and its output will be the input of the motor driver. Then the motor driver will make the DC motor to function. The GUI consists of clockwise, counterclockwise, and stop buttons by which, when clicked, runs. The track bar controls the speed of the motor. 0255 represents the speed of the motor. When you move the track back from left to right, the motor speeds up, and when you move it from right to left, it speeds down. So in terms of the GUI again, our professor said that this is not required. So for the procedures, first setup. This is how you would set up the computer and Arduino microcontroller if you are to use the kit on an actual basis. But since I don't have, I would be setting up the this circuit diagram here, schematic diagram rather, using the Tinkercad application. So also this one, connect pin 2 and pin 7 of the IC to pin 4 and pin 5 of the microcontroller. I would be doing this using the Tinkercad. So for the first part of the experiment, or the first problem, the question: create a program that will control the direction of the motor by sending character message to the microcontroller. Sending character A will make the motor rotate clockwise, and sending character B will make the motor rotate counterclockwise. Sending character C will cause the motor to stop. So first, I made this schematic diagram via Fritzing schematic mode. So here is the schematic diagram. So let me show you the Fritzing app. So here it is. And this is from the breadboard that I constructed here from the circuit. There. Next, the circuit assembly. This is the circuit assembly for the circuit to solve the problem. I made this via Tinkercad. So let's check on Tinkercad. Here is the circuit. So this is how I connected the circuit. I used this given schematic diagram. So we're asked here to connect the DC motor to the power amplifier IC as shown below. So here I just pasted a pin output for L293D. So um, this is the first pin. So as you can see here, the first pin is connected to the power supply. So here it's connected to the 5 volt of the Arduino. And so as this pin right here, and next pin 4 here connected to 4 of the Arduino. This the second pin rather connected to pin 4 of Arduino, and the motor here pin 3 connected to the motor. Next, this right here should be connected to the ground, and pin 5 here connected to the motor too. Yeah, 1 2 3 4 5 pin 6 rather connected to the pin 5 here of the Arduino, and this pin 5 here of the IC is connected to the switch. So again, let me just repeat: pin 1 2 3 4 5 6, output 2 is connected to the motor, and this input 2 is connected to 5 of the Arduino. Next, this pin right here connected to the motor, or the power supply, and also the power another end of the power supply is connected to the ground of the IC. For the first part of the experiment, the first problem, this is the code. So this is the circuit, and this is the code. For the first part, I've made this comment note here for me to be reminded that enable 1 is at pin 9, output 1 is at pin 4, output 2 is at pin 5 of the Arduino. Next, the variables: character, control motor. This is for the input for motor A, B, and C value. The integer, the motor speed. This is the speed integer of the motor, and of course the output PWM for the integer of the PWM pins. So let's head on to the main code. As we can see here, the first part enables the serial port for the baud rate. It enables a serial port and sets the baud rate. Next pin mode is as 9, 4, and 5 for output. This is its equivalent. And the direction is of course from low to high for it to work, the rotation of the motor. And the void loop, this part of the code here, is the motor direction and behavior code. So it says here that motor speed, that the program will run with if motor speed is equal to the analog read. So what it would read here if in our serial monitor. So if what it would read is, for example, A, B, or C, then there the speed, this is the set value that I've mapped, and the analog write would output the PWM, or will tell the PWM output. And next, control motor serial dot read. So switch control motor. So as we can see here, if A is being inputted, the digital write, the motor would rotate clockwise because it would read 4 to 5, it which is set here as low to high, so that is clockwise. And it would also print this clockwise in our serial monitor. So next, case B, then this would rotate counterclockwise, which as you can see here, high to low naman. And of course, print counterclockwise. And of course, case C, low to low, means it would stop. And it has a serial print here, or it would display stop. So let's try the simulation. So as you can see, initially it starts at turning. So let's stop it with character C. There, it stopped and it says here stop. Now let's turn it clockwise. There, it's turning clockwise, and then note here clockwise, and I'll stop it again, and then I'll be counterclockwise and stop. There. So the next part of the experiment, this is the second problem. Create a program that will control the speed of the motor by controlling the pulse width of the microcontroller. The width of the pulse depends on the sent integer, take note of that, to the microcontroller ranging from 0 to 255. Sending 0 will cause the speed of the motor to the slowest, or to stop, and 255 will cause the speed of the motor to the fastest. So this is the schematic diagram. I used the same schematic diagram and circuit for both of the problems, since it happens to be the same, just the code are different. So here it's the same. So for the second part, or second problem of the experiment, this is the code. As you can see here, I've put description. This is to note that enable 1 is 9 in our Arduino Uno. Output 1 is 4 in our Arduino Uno, and output 2 is 5 in our Arduino Uno. These are the equivalent pinouts for our guide in making our code. So first, string motor control. This is the variable for us to control the motor and the speed of the motor as a string. Next, integer motor speed. This is the speed of the integer. This is the speed integer value of the motor. So this value is a number. And next, the main code itself, void setup, serial begin. This is the baud rate value. This is where you enable the serial and set the baud rate value. And pin mode, just like what I mentioned earlier, when we enable 1, that is 9 in our Arduino, and this 4 right here is our output 1. This is connected to the motor, and pin mode 5 is also an output, is connected to our motor also. Next is motor direction, digital right 4 low, digital right 5 high. This is the direction of the motor, which is clockwise. Void loop, this is for the serial monitor, for us to be able to input the number in a number for the speed of our motor. So if serial dot available, or if there is a available number or inputted data, then the motor will be equal to the serial dot read string. It is a string variable because we would only want a number answer, or we would only want a number inputted in our serial monitor and not a letter or a symbol. So if a number is being entered, then else the motor speed will then be equal to the motor control dot to integer. This will convert the string to integer, and then it would print in the serial monitor, just like we see here. This is because I run the application earlier. It says here enter desired speed, numbers 0 to 255 only, because that's what asked of us from the experiment. And also it would analog write the motor speed, which is using the pin mode 9 here, in the IC. Uh, this is where the data would be inputted, and then it would print the serial or display the motor speed data here. As you can see, it's 0 because it's currently not working. And this is the most important part of the code, the map motor speed. This is the value of the, this is where the simulation would refer its value motor speed 0 to 255 to 55 to 0. This is the map formula value from high to low to high. So let's check if the simulation works. There, as you can see, there's no entered value for our desired speed. So if we are to enter, let's say 50, you can observe that the motor turns, and let's try to make it faster. 100. There, it moves faster, it rotates faster rather. And 255. There. And let's stop it. 0. There. Next, part C, graphical user interface. So again, we were not asked by our professor to make these, so I guess we're done. Again, this is laboratory activity number 1 for robotics laboratory subject, DC motor controlled with computer microcontroller interfacing. I'm Alexandra May Bihoya from ECE 41, and thank you.